Hello everyone. In this video, we review test 2. You will have 26 questions, I believe. Actually 24. You will have 24 problems for test 2. All of them are multiple choice question. Number one, we have y to the power 4 times y to the power 2nd times y to the power 5th. Multiply powers with the same base. We keep the base and add the 3 exponents, 4 plus 2 plus 5. We have a y equals 11. We applied the product rule here. Multiply to 2 powers with the same base. We keep the base, add their exponents. Because y to the power 4th is y times y times y times y. Y squared is 2y's. Y to the power 5th is 1, 2, 3, 4, 5. So if you count the total number of y's in the product, that is 11. Number 2, we are going to simplify x to the power 10th over x to the power 4th. Simplify this quotient of 2 powers with the same base. By the quotient rule here, we are going to keep the base, take the difference of the 2 exponents, use the exponent in the numerator minus the exponent in the denominator. 10 minus 4 equals 6. The answer is x to the power 6. Or you can look at this problem this way. Numerator, x to the power 10th. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10x in the numerator. X to the power 4th. 1, 2, 3, 4. 4x as factors in the product. If numerator and denominator of a fraction have a common factor, then a common factor could be cancelled. So this will be cancelled, cancel, cancel, cancel. They cancel each other, they become 1. Denominator becomes 1. Numerator, we have 1, 2, 3, 4, 5, 6. 6x there, and that gives us x to the power 6. Number 3. X to the power 4th over x to the power 10th. Power rule again. Quotient rule again. Quotient rule. We keep the base and we take the difference of the 2 exponents. We use the exponent in the numerator minus the exponent in the denominator. 4 minus 10, negative 6. To get rid of the negative exponent in the expression, we use 1 over x to the power 6. So number 3, we apply 2 formulas. One is the quotient rule. The other is the negative exponent formula. Another way to deal with number 3 is use the definition of exponentiation. X to the power 4th over x to the power 10th. X to the power 4th, 1, 2, 3, 4. 10 power of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we cancel this one, this one, this one, this one. And numerator becomes 1. Denominator becomes x to the power of 6 because you still have 6x left as factors in the denominator. That is number 3. Either method will be okay. Number 4. Number 4 is a simple problem, a straightforward application of a power rule. Power rule, x to the power of m and then to the power of n equals x to the power of m times n. We multiply the two exponents when we apply power rule. We have x to the power of 2 and then to the power of 4. We keep the base x and we multiply the two exponents. 2 times 4, power of 8. Number 5. Number 5, we have a base which is 3x squared to the power of 3. Look at the structure of this expression. The expression is a power of product. The base is a product. 3 is a factor. X squared is a factor. The base is a product of 3 and x squared. The product of the green and the blue. By the power of a product formula is right here. Power of a product equals the product of powers. We can write the expression as 3 to the power of 3 times x squared to the power of 3. So green cube multiplied by blue cube, right? 3 cube, 27. X squared and then to the power of 3. By the power rule, we multiply the two exponents. 2 times 3, 6. The final answer is 27 multiplied by x to the power of 6. So number 5, problem number 5, we apply two formulas. Power of a product first, power rule after. Number 6, simplify the expression. Negative 2y squared over x and then to the power of 3. The structure of this expression is the power of a quotient. Power of a quotient. Power of a quotient equals quotient of powers. So we can write the expression as power of the numerator over power of the denominator. So you can see the cube of the blue over green equals cube of blue over cube of green, right? Power of quotient equals quotient of powers. We continue to simplify the numerator and the denominator separately. Numerator right now is a power of product. Power of product. So we have negative 2 cube times y squared and then to the power of 3. Make sure you see this step. In order to simplify the numerator, we applied the formula power of a product equals product of powers. Cube of negative 2 y squared equals cube of negative 2 times cube of y squared. The denominator is simplified already, we just copy it. Cube of negative 2, negative 2 times negative 2 times negative 2, negative 8, right? Y squared and then to the power of 3 by the power rule. We multiply the two exponents, 2 times 3, 6. That is y to the power of 6. That's the final answer for number 6. This problem, actually, we applied quotient rule. And then we applied, so we firstly applied the power of quotient. And then we applied the power of product. And also we applied power rule. So we applied 3 formulas for number 6. Number 7, we have a formula tells us for any non-zero quantity, the zero exponent of the quantity is 1. So you can see half to the power of 0 is 1. Negative half to the power of 0 is 1 as well, right? 1 plus 1, you have 2. Any quantity, as long as the quantity is non-zero, to the power of 0 always gives you 1. The same here. Any base, as long as the base is non-zero, is raised to the power of 0 always gives you 1. Number 8. We need to simplify 8 to the power of -2. The formula we're going to apply is right here. How do we get rid of the negative exponent? We simply remove the negative sign in the exponent, and then we write the leftover on the bottom. 8 to the power of 2. We use 1 to over 8 to the power of 2. And the final answer for number 8 is 1 over 8 to the power of 2. Let's see number 9. Number 9 is an addition of 2 polynomials. Since in my notes, I applied 2 different methods to take the sum of the 2 polynomials. Here in the video, I'm going to only apply one method, vertical method. I'm going to write the first polynomial on the top. I look at the first polynomial. The leading term is 3x to the power of 6. And then we have -3x to the power of 5th. We also have x to the power of 4th. The last term is -2. The second polynomial also contains 4 terms, and they are x to the power of 6 term. Actually, it's 6 to the power of x. 6 multiplied by x to the power of 6. 5x to the power of 5th. -4x to the power of 4th. Minus 8. Make sure that you align the like terms in the 2 polynomials if you apply the second method, the vertical method. Now we know the 2 polynomials are placed vertically and their like terms are aligned. We are ready to add them up. Vertically, 3 plus 6, 9. 9x to the power of 6. -3 plus 5, +2, x to the power of 5th. 1 minus 4, -3, x to the power of 4th. -2 minus 8, -10. That's the addition of the 2 given polynomials. Number 10, subtraction. In a note, I applied the 2 different methods, horizontal method and the vertical method. In this video, I'm going to just apply one method, the vertical method. I'll put the first polynomial above, -7x cubed plus 10 x squared plus 4. Use that polynomial to minus second polynomial. The second polynomial, -5x cubed plus 2x minus 5. And we are going to translate that or convert that to addition. So right now is a subtraction. I'm going to convert that as an addition. Copy the first polynomial. Copy the polynomial above on the top. Change the minus to plus. And change all the signs in the second polynomial. This one is negative, right? You're going to write that term as a positive 5x cubed. And this is a positive 2x. You are going to write that as a -2x. And this one is a -5. You are going to write that as a +5. and then you add them up vertically. -7 plus 5, -2. +10 minus 2, +8. I miss a square here, I believe. Oh no, they are not aligned, right? Yeah. So we are going to fix this part. So the second polynomial is -5x cubed plus 2x minus 5. So when you notice that the first polynomial actually missing a x term, you can rewrite the polynomial as -7x cubed plus 10x squared plus 0 times x plus 4. And then minus the second polynomial is -5x cubed plus 0x squared, because the second polynomial is lacking a x squared term, plus 2x minus 5. Yeah, so it's very important we have those like terms aligned in the two polynomials. And now let's convert to addition. Copy the first polynomial, change the subtraction to addition. For the second polynomial, we are going to write the terms to its opposite. -5 x cubed, we're going to write that as +5 x cubed. 0 x squared, we're going to write that as -0 x squared. It really doesn't matter because 0, opposite of 0 is still 0. And we write 2x as -2x. -5 as +5. And now we are ready to add them up vertically. -7 plus 5, -2. 10 minus 0, 10. 0 minus 2, -2. 4 plus 5, 9. And the subtraction of the original two given polynomial is this polynomial. Okay? Yeah. Very important. You need to make sure if you apply the vertical method, you need to make sure the two polynomials, they have their like terms aligned. That's number 10. Number 11. Number 11. We have two functions, f of x, which is a quadratic function, degree 2. G of x is a linear function, degree 1, 2x plus 1. We are looking for f minus g of 4. Notation-wise, we covered this on Monday. F minus g of 4 represents f of 4 minus g of 4, right? So we need to find f of 4 and g of 4 and then find their difference. Let's see what is f of 4. F of 4, plug in, is 4 squared minus 3. 4 squared is 16. 16 minus 3 is 13. G of 4, for the function g, which is the linear one, which is the linear function, we plug in x equals 4. 2 times 4 plus 1. 2 times 4 is 8. 8 plus 1 is 9. And f of 4 minus g of 4 becomes 13 minus 9, and that is 4. For this type of question, I would recommend you utilize your calculator. I don't want you to lose the point because you mess up the calculation. Number 12. Number 12, let's see. Okay. Number 12, actually, let me remove this. Number 12 is we simplify this product. It's a monomial, univariate monomial, times a multivariate monomial, 6x to the power of 10, y to the power of 6. Yeah. So that is a multiplication of two monomials. The structure of the whole expression is one product, one multiplication. We know in the multiplication, the order of the factors does not matter. So we're going to rearrange the factors in the product. We're going to put a -3 and a 6 together, x squared, x to the power of 10 together, and y to the power of 6 here. -3 times 6, -18. X squared times x to the power of 10th. By the product rule, keep the base, add the exponents, 2 plus 10, 12, times y to the power of 6. The multiplication of the two monomials is another monomial. Number 13. We have two functions given. Function f, 5x plus 4, linear function. Function g, 3x minus 8, linear function. We need to look for fg of x. What does the notation mean? Fg of x means f of x times g of x. So this problem actually is to multiply two binomials, 5x plus 4 times 3x minus 8. There's a technique we have learned to multiply two binomials called FOIL, F-O-I-L. So we are going to FOIL to have the expansion of the multiplication. First times first plus, outside times outside plus, inside times inside plus, last times last. The two first terms are 5x, 3x, first. Outside, 5x, times -8. Those are the two terms on the outside. The two terms on inside are 4 and 3x. The two last terms in the two parentheses are 4 and -8. 5x times 3x, 15x squared. 5x times -8, positive times negative, -40x. 4 times 3x, 12x. 4 times -8, -32. We notice the two terms in the middle. They are like terms. Combine them. We have the final result, 15x squared minus 28x minus 32. -40x plus 12x is -28x. When we combine like terms, we combine their coefficients. Number 14. Two functions are given. F of x is a quadratic function, x squared minus 3x plus 5. G of x is a linear function, 4x minus 1. We are looking for fg of 4. We need to understand the notation. The notation means f of 4 times g of 4. F of 4 equals 4 squared minus 3 times 4 plus 5. use your calculator to assist you to find the value of the function f as x equals 4. 4 squared 16. Negative 3 times 4, negative 12 plus 5. 16 minus 12, 4. 4 plus 5 is 9. F of 4 is 9. G of 4. Plug in x equals 4. 4 times 4 minus 1. 4 times 4, 16. Minus 1, 15. So fg of 4, which is f of 4 times g of 4, would be the multiplication of 9 and 15. Use your calculator. Multiply 9 by 15. You have 135. In my notes, I offered 2 different methods. In the video, I applied the second method. It's more convenient. Number 15. We have 2 functions are given. Function f, 6x squared minus x. Function g, 2x. 1 quadratic, 1 linear. We are looking for f over g of x. We need to understand this notation. This notation means f of x over g of x. So the quotient of 2 polynomials, division of polynomials. Numerator is a binomial, 2 terms. Denominator is a monomial, 1 term. We're going to use each single term in the numerator to divide by the monomial in the denominator. So we have 6x squared over 2x plus negative x over 2x. 6x squared over 2x, 6 over 2, 3. X squared over x, x. Negative over positive, so negative. X and x cancel each other. We have 1 over 2. So that's the quotient of the division of f and g. What we need to know about the domain of x is, since the denominator, this is the denominator, right? Since the denominator is 2x, x has to be non-zero. So x has to be not equal to 0. Otherwise, the denominator equals 0, the expression is undefined. Number 16 is division of 2 polynomials as well. F of x, the dividend, x squared plus 15x plus 54. G of x, divisor, x plus 9. We are going to use a long division to find the quotient. Firstly, we need to make sure both of the 2 polynomials are in the standard form. F of x has degree 2. It does have 3 terms, and the 3 terms are arranged in order, in the descending order of the exponents. Square, x squared plus 15x plus 54. And the linear function has degree 1. 1 plus 1 is 2. And it does have 2 terms, and the degree and the 2 terms is arranged in the descending order of the exponents. So let's see, how do we apply long division to find the quotient. We place the dividend in the symbol x squared plus 15x plus 54, and place the divisor to the left of the division symbol. Remember, we have a process: divide, multiply, subtract, compare, bring down. So first step, divide. We are going to use the first term in the dividend to divide by the first term in the divisor. So x squared over x, that is x, right? We are going to put the quotient x right above the notation, division symbol. And make sure it's aligned with its like term, right above 15x. And we multiply the quotient x by the divisor. Distribute x times x, x squared, x times 9, 9x. And we go ahead to write the product right below the dividend, x squared plus 9x. Subtract. We change the sign of the blue polynomial. Positive becomes negative, positive becomes negative, and then we do the addition. X squared plus negative x squared, 0. 15x minus 9x, 6x. Compare. 6x has degree 1. The divisor also has degree 1. The remainder does not have lower degree than the divisor. So we continue the process, bring down the next term, 54. And this polynomial is going to be the new dividend. And we are going to do the process again, divide. We use the first term in the pink polynomial to divide by the first term in the divisor. Quotient is 6. We put a 6 right above 54. Multiply 6 by the divisor. Distribute 6 times x, 6x, 6 times 9, 54. And we put 6x plus 54 right below the pink polynomial. We do the subtraction. Remember, we change the sign first and add them up. You can see they are opposite of each other, right? 6x, negative 6x, 0. 54, negative 54, 0. Remainder is 0, and the quotient is x plus 6. So the quotient is x plus 6. One thing I want to point out is when we divide f by g, g is x plus 9. As a denominator, x plus 9, the orange part, this part, x plus 9 has to be non-zero. If x plus 9 is not equal to 0, you minus 9 from both sides, you have x not equal to negative 9, right? So for x, you have to be able to identify the excluded value. X cannot be negative 9. The final answer would be x plus 6, that's the quotient, and x not equal to negative 9. You're going to look for the answer choice, which is the same with this. Number 17. Number 17 is a composite function. We have f of x equals x squared plus 3. G of x equals 2x plus 1. We look for G circle f of 6. We need to translate the notation first. It's G of f of 6. We want to find f of 6 first. Since f of x is x squared plus 3, f of 6 would be 6 squared plus 3. 6 squared, 36. 36 plus 3 is 39. So f of 6 is 39. They are equal to each other. then we could replace f of 6 with 39 now. G of 39. F of 6 and 39, they are the same, right? We substitute 39 for f of 6. Now we are looking for g of 39. Function g is 2x plus 1. G of 39 would be 2 times 39 plus 1. 2 times 39, use your calculator. That will give you 78. Plus 1, you will have 79. So G of 39 equals 79. That will be the final answer for number 17. Number 17. Number 19. Number 18, I mean. Number 18. Number 18. Given two functions, f and g. F is 3x plus 2. G is x squared minus 3. We need to look for f circle g of x. Translate or interpret this notation first. The notation means f of g of x. We can start from the inside first. We start from the inside. G of x is x squared minus 3. So we replace g of x with x squared minus 3. So we are done with function g. For function f, since the output always equal to 3 times the input plus number 2, we would have f of the input, let's say whatever the input is, let's say is color blue, equals 3 times the input plus number 2. 3 times the input plus number 2. F of star equals 3 star plus 2, right? Then f of blue would be 3 times blue plus 2. It's just that the blue here is x squared minus 3. Let's distribute. 3 times x squared, 3x squared. 3 times negative 3, negative 9 plus 2. So that is 3x squared minus 7. Final result, final answer of number 18 is 3x squared minus 7. Number 19. An equation that defines y as a function of x is given. Solve for y in terms of x and replace y with the function notation f of x. So this is how you handle number 19. You are given an equation. The equation actually is a straight line, right? We learned the formulas for straight line in previous chapters. And we are going to solve this equation for y. In order to solve this equation for y, we need to get rid of everything from the left beside except y. Firstly, we want to get rid of 3x. We minus 3x from both sides. Cancel. And we have a negative 5y equals negative 3x plus 10. Or 10 minus 3x. They are the same. One more step to isolate the y. Coefficient of y is negative 5, right? Coefficient of y is negative 5. And we're going to divide both sides of the equation by negative 5. Divide by negative 5. Negative 5 over negative 5 is 1. We have y equals 10 minus 3x all over negative 5. The actual result, actual problem would have the correct result just like this one. You can pause the video and or rewind the video to look at this part a few more times, especially read the instruction here. the instruction actually tells you what to do. What do you do with this equation? And the last step by the instruction, we change y, replace y with f of x. Yeah, so your final answer is supposed to be f of x equals 10 minus 3x all over 95. Number 20. For the polynomial function, find the requested value. This is a very simple problem. You are given a function, linear polynomial function, negative 2x plus 3. You are looking for f of 6. You see, you only need to replace x with the 6, or substitute the 6 for x. In other words, you're going to put or place 6 in the position of x. The input is 6 in this case. So we have a negative 2, copy negative 2. Do not copy x, instead put a 6 there, plus 3. Negative 2 times 6, negative 12, plus 3, negative 9. The final answer is a negative 9 for number 20. Number 21, find a graph for f of x equals x squared minus 2. This is exactly the same with the problem you're going to see in the test. Just know the function is a polynomial function with degree 2. We have learned a polynomial function with degree 2 is a quadratic function. The graph of a quadratic function is a parabola. Parabola either opens up or opens down. If the leading coefficient is bigger than 0, is positive, then the parabola opens up. If the leading coefficient is negative, then the parabola opens down. In our case, x squared minus 2, look at the blue polynomial, has a leading coefficient 1, which is positive. So the result is a parabola opens up. And you're gonna, for number 21, you're gonna look for a graph like that and choose that answer. So please don't lose a point on 21 because it's just exactly the same with the problem. Number 22, we have a function f, which is 3x squared minus 5. You might remember on Monday, I made you to write down a sentence in your notes. The domain of all the polynomial functions is all real. So as a polynomial function, the domain of this function is all real. We use negative infinity to positive infinity to represent all real. For the range, we need to think about the graph of this function. For the range, leading coefficient, this is a quadratic function. Leading coefficient is positive. So the graph of this function is a parabola opens up. The range would be all the values of y. The function has a minimum value at a negative 5. How do we know that? Because this part is bigger than or equal to 0, right? Because it's 3 times x squared. So the orange part is bigger than or equal to 0. If you minus 5, then the whole function is bigger than or equal to negative 5. Bigger than or equal to negative 5. That's how do we know? The range is negative 5 to positive infinity. Number 22 might be a bit challenging. You need to understand the definition for range very well. The domain is all real. As I said, the domain for any polynomial function is all real, from negative infinity to positive infinity. The range instead is not all real. It has a minimum if the leading coefficient is positive. I explained why. the orange part is bigger than or equal to 0. So the whole function is bigger than or equal to -5. So let me show you this way. The orange part, 3x squared, is bigger than or equal to 0, right? And you minus 5 from both sides. You have 3x squared minus 5 bigger than or equal to -5, right? And what is 3x squared minus 5? Your y. Y is bigger than or equal to -5. So your y value has a minimum value -5. That gives the range from -5 to positive infinity. Number 23 is a polynomial function with degree 3. Remember, on Monday, we have this knowledge covered, the content, saying the graph of a polynomial function with degree 3 always look like this way or this way, you know. And you can tell for any polynomial functions with degree 3, both of the domain and range are all real. Both of the domain and range are all real. So you're going to choose negative infinity to positive infinity for both domain and range. That's number 23. Number 24, graph the function x cubed minus 1. Among the answer choices A, B, C, D, you're going to look for something like this or like this. Yeah, only one of them has a curve shape that matches the graph of a polynomial function degree 3. And this is the graph that you need to look for, number 24. All right, email me if you have any question. Thank you for watching.